Hello friends, in this video we shall discuss with respect to Electronic Science paper of TNSET which was conducted on 6th March 2025. The total number of questions that was asked in paper 2 is for 100 and the marks allotted is 200. So in this part 1 video I am going to cover from question number 1 to question number 25. Let us move on to the first question. In the first question what they have given is, we are going to consider operational amplifier MUA741. They are going to provide the input voltage of 10 volts. Assume the sleeve rate is 0.5 volts per microseconds. How much time it is taking for the replication at the output end? We know that sleeve rate is defined as what is the corresponding change in the voltage level, nothing but I am going to take it as a delta V divided by what is the time taken. So usually the time taken will be 1 microseconds. So this is how you are going to define the sleeve rate. But in this question they have given the sleeve rate as 0.5 volts per microsecond, which is equals to what is the output level they are expecting, which is equals to 10 volts divided by what is the amount of time that is required is I am going to take it as delta T. So delta T is given by 10 divided by 0.5, which is equals to 20. 10 volt divided by 0.5 volt per microseconds. So micro will be shifted over here. So the corresponding option that is going to follow is option 1 is correct, nothing but 20 microseconds. In the second question what they have given is, this question is from logic design or digital electronics and it is from combinational part. This is x complement y complement connected to a NAND gate. What we are going to get is x bar into y bar the whole complement you are going to get. Similarly, this one here we are going to get xy the whole bar. Here we are going to get z bar. What is the output at this end we are going to get? It is x bar into y bar the double complement you are going to get. Here what is the output you are going to get? X into y into bar. Again for this negation you are going to get a double complement. And what is the output at this end? We are going to get a z double bar. So these three things you need to add, nothing but since we are going to make use of an OR gate, we are going to make an addition kind of thing, logical addition. So f will be equals to double complement will be getting cancelled, x bar into y bar plus x into y plus z you are going to get. Such a simple question they have asked. So for this, the corresponding option that's going to follow is option C is correct. Nothing but xy plus z plus x bar y bar. You can write x bar y bar or you can write x dash y dash, all means the same. What is the efficiency eta of the network during maximum power transfer? So we know that in the network analysis we have studied the maximum power that will be transferred from source to load will be just 50%. Whenever you will be having the impedance matching, strictly speaking it is conjugate. In terms of resistance, if I am defining, RS will be equals to RL. At that time you are going to get a maximum power that will be transferred, that is just 50%. So the corresponding option that is going to follow is option 2 is correct. In the fourth question what they have given is, what is the content of the register R1 after executing the following instruction? Clear C. Clear C is nothing but clearing the contents of the carry flag. Then what they have given is, the value of register A will be copied with an immediate data, that is 4CH. Then again you are going to subtract this one with 6EH. Then you are going to check for the carry flag contents. Now look at the things. Whenever you have performed lower number subtracted with a higher number, what is the scenario you are going to get? The carry flag contents will be equals to 1. The carry flag contents will be equals to 1 over here. Now look at the things. What is the value, that is 4C minus 6E? If you are not in a position to solve, what you can do is you perform 6EH minus 4CH, then whatever the result you are going to get, take a 2's complement of it, you are going to get the answer. So what is the value of 6E? In the binary, how you are going to write 6E? 0110 11110 for E. Similarly, for 4, you're going to write it as 0, 1, 0, 0. For C, you're going to write it as a 1, 1, 0, 0. Then what you're going to do? You're going to subtract. Once you're subtracting, what is the value you're going to get over here? It is a 22H. It is a 22H you're going to get. But 22H, if they have given in the option, you would have opted it. You would have opted it. Next, what you have to do? You have to do what? You have to do what? Take a 2's complement. When you are taking a 2's complement, it is nothing but 1's complement plus 1. So, replacing 1's by 0's and 0's by 1. So, what are you going to get? 1, 1, 0, 1, 1, 1, 0, 1. For this, you need to add 1 to it. When you're going to add 1 to it, you're going to get 1, 1, 0, 1 and a 1, 1, 1, 0. What is the option which will be following? The corresponding option that's going to follow is option D is correct. In the fifth question, what they have given is the ripple voltage of a full wave rectifier with a 100 microwave filter capacitor connected to a load drawing a current of 50 milliampere is. The formula is the ripple voltage is given by 2.4 times of VDC divided by RL times of C. We know that VDC divided by RL will be equals to IL. So, on substituting, what you are going to get? What is the value of IL they have given? The value of IL will be 50 milli and the value of the capacitance they have given it is 100 micro. So, what is the value of VR you are going to get? The value of VR will be equals to 1.2 volts. The value of VR will be equals to 1.2 volts. Direct substituting and getting the answer. In the sixth question, what they have given is the 8051 microcontroller contains. What it is going to contain? It is going to contain 4 8-bit parallel ports. It is going to contain 4 8-bit parallel ports. PORTS, right? So, what and all the ports you will be having? Port 0, port 1, port 2, port 3. Port 0, port 1, port 2, port 3. Or you can also define the ports as a port A, port B, port C and port D. Port A, B, C, D. Like this also you can able to define. It is a bit addressable as well as byte addressable. It is a bit addressable as well as byte addressable. How many ports you will be having? 4 ports you will be having. Corresponding option that is going to follow is option C is correct. In the seventh question, what they have given is in a full adder having 2 inputs A and B, the outputs sum and carry out, you will be getting the output. What is the Boolean expression for sum and carry they are asking? We know that this half adder is a combination circuits which is going to accept 2 inputs, namely A and B, which is of a single bit wide, and it is going to produce 2 outputs. One is sum and carry. What is the expression for sum you are going to get, which is equals to A XOR with B you are going to get, or which is equals to A bar B plus AB bar. Similarly, carry expression you are going to get A into B. The corresponding option that is going to follow is option B is correct. In the 8th question, what they have given is identify the correct statement with respect to the polynomial. There are 1 root with respect to positive real part they have given, it is wrong. Now look at the things, all the poles are lying on left half of S plane. One pole is at S plus 1 means it is S minus of minus 1. So the pole location is at minus 1. Next pole is at minus 2. Another pole will be at minus 3. Another pole will be at minus 4. So, A option is wrong. There are 3 roots with positive real part. There are no any roots with a positive real part. And there are infinite root with positive real part. This is also wrong. There are no roots with respect to positive real parts. D option is correct. For 8th question, the corresponding option that is going to follow is option D is correct. Find the power rating of a Zener diode with test current equals to 12.5 milliamperes and Zener voltage is 10 volts they have given. Now look at the things carefully. What is the power rating? How we are going to express the power rating? The power rating is expressed in terms of voltage and current, IZT into VZ. What is the value of current you are going to get? 12.5 milli into. What is the value of Vz? You are going to get a 10, which is equals to 125 milli, which is equals to 125 milli. The corresponding option that is going to follow is look at the things, don't go with unit, don't go with unit, it will be 125 milliwatt. 125 milliwatt, because power is nothing but voltage multiplied by current you are going to get. Corresponding option that is going to follow is option C is correct. In the 10th question, what they have given is, they have given the circuit and this is from analog electronic subject. What they have given is a VBE voltage which is equals to 0.7 volts. They are asking what is the value of R2 and RE. Take IC is approximately equals to IE. Now look at the things. We know that in order to turn on this transistor, we have to apply VBE which is equals to 0.7 volts. Across emitter you are going to have 1.3 volts. Then what is the value of VB? VB you are going to get which is equals to 2 volts. VB you are going to get 2 volts. Now whether the transistor is on or off, you are applying some voltage at the collector. So the transistor is turned on. How you are going to say that the transistor is turned on? VB equals to 0.5. Then when the transistor is turned on, in which region it is operating? We know that the collector voltage is greater than the base voltage. So the transistor is operating in a linear region. The transistor is operating in linear region. So what are you going to get? VC will be greater than VB. VC will be greater than VB. Now what is the value of collector current IC? What is the value of collector current IC? So the current is flowing from VCC to VC. So it is 10 minus 6 divided by 4K. 10 minus 6 divided by 4K. Which will be equals to 1 milliampere. Which will be equals to 1 milliampere. Now what is the value of RE? So this is approximately equals to IE. This is approximately equals to IE. Now what is the value of RE you are going to get? The value of RE will be equals to VE divided by IE. What is the value of VE, which is equals to 1.3? What is the value of IE, which is equals to 1 milli, which is equals to 1.3 kilo ohms. What is the value of RE, which is equals to 1.3 kilo ohms or 1300 ohms, or you are going to get 1300 ohms. So the value of RE will be equals to 1300 ohms. Corresponding option that is going to follow is option A is correct. Now look at the things carefully. What is the value of R2? What is the value of R2? Try to calculate what is the value of I1. The same current will be flowing through I2 also. Nothing but R2 also. Why? The base current will be very small. The base current will be very small. What is the value of I1 we are going to get? The voltage level will be varying from 10 minus 2 divided by 80K. 10 minus 2 divided by 80K. So this current will be equals to 8 divided by 80, which is equals to 0.5 milliampere, which is equals to I2, which is equals to I2. Now what is the value of R2 you are going to get? R2 which is equals to VB divided by I2 you are going to have. What is the value of VB you are going to get? 2. What is the value of I2 you are going to get? 0.1 milli. 0.1 milli. What is the value of R2 you are going to get? 20 kilo ohms. The value of R2 will be equals to 20 kilo ohms. What is the corresponding option that is going to follow? The corresponding option that is going to follow is option 1 is correct. In the 11th question, they are asking what is the on period and off period of a stable multivibrator that is going to oscillate at 50 kHz at a 60% duty cycle. We know that a T on will be equals to alpha times of capital T. T is the time period. Alpha is the duty cycle, right? So what is this T on, which will be equals to 60 divided by 100 times of what is the time? The time will be equals to 1 divided by 50 kilo. 1 divided by 50 kilo you are going to get. So what is the value of T on you are going to have? The value of T on will be equals to 0.012 millisecond. 0.012 millisecond. what is the value of T off you are going to have? T off will be equals to 40%, it is in the off state, 40 divided by 100 into 1 divided by 50. What is the value of T off you are going to get? The value of T off will be equals to 0.008 millisecond. 0.008 millisecond. So, the corresponding option that is going to follow is option 1 is correct. For the 11th question, option 1 is correct. 12th question, simple question from combinational circuits. What will be the output F they are asking? Now look at the things. This will be equals to A into B into C the complement. This will be D the complement you are going to get. What is the output you are going to get? A into B into C the complement into D the complement, the whole complement, which will be equals to ABC double complement that is going to get cancelled plus DE double complement that is going to get cancelled. So what is the answer you are going to get? You are going to get ABC plus DE. So the corresponding option that's going to follow is option C is correct. In the next question what they are given is find the transconductance GM they are asking. We know that the transconductance GM is defined as dou ID divided by dou VGS. Dou VGS, which is equals to ID2 minus ID1 divided by VGS2 minus VGS1, which is equals to what is the value of dou ID? You are going to get 4.3 milli divided by 1.25. What is the value of GM you are going to get? In the 14th question what they are given is the D flip-flop can be obtained from JK flip-flop as you are going to connect a NOT gate, that's it. You are going to connect a NOT gate and then you are going to realize from JK flip-flop. In the case of T flip-flop, what you are going to do is you are going to make use of shorted one. J and K are shorted. That's it. In the 15th question, what they are given is the conductivity of the silicon is 10 per ohm per centimeter. Determine the drift current density J if an electric field density of what is the value? 15 volt per centimeter. Now look at the things. The drift current density is given by J equals to sigma E. What is the value of conductivity? You are going to get 10 per volt per centimeter into what is the value of electric field? You are going to get 15 volt per centimeter. So volt divided by ohms, which will be equals to amperes you are going to get. So which is equals to 150 amperes per centimeter square. 150 amperes per centimeter square. The corresponding option that is going to follow is option D is correct. Let us move on to the 16th question. Till now, if you have not liked the video, please like this video, share this video with your friends, and don't forget to subscribe to my channel, Craving Gyan. Which one of the following circuit is an inductive transducer? Directly we can say option C is correct, which is an inductive transducer. What is the definition of a transducer and what is the definition of a sensor? Important. Non-electrical signal to electrical signals you are going to convert, and from one form to another form. This is the definition. If you are going to make use of pure resistive network, it is a resistive transducer. If you are going to make use of inductive network, it is an inductive transducer. If at all, if you are going to make use of a capacitive network, it is a capacitive transducer. That's it. For this curve, you are going to get A divided by sigma plus j omega. For right side, you are going to get A divided by sigma minus j omega. Sigma minus j omega. Now, when you try to add this, you are going to get option D as correct. So, for 17th, option D is going to follow. In the 18th question, little bit tricky question. What they are asking is what is the value of collector current IC and what is the value of other sets of currents? Let us try to find out. Given VB equals to 0.7 volts. So, this voltage I am going to take it as 0.7 volts. This voltage I am going to take it as 0.7 volts. Now, what is the value of emitter voltage, which will be equals to 3.3 volts. The emitter voltage will be equals to 3.3 volts. Important. Now, given the value of beta, let us try to calculate what is the value of IC. IC equals to alpha times of IE. What is the alpha? Beta divided by 1 plus beta multiplied by. You are going to have the currents IE. We are going to have the currents IE. What is the value of IE current you are going to get, which is equals to 3.3 divided by 1 kilo, which is equals to 3.3 milliamperes. What is the value of beta they have given? 50 divided by 51. What is the value of IE, which will be equals to 3.3? Closest one you are going to get. What is the value of IC? IC equals to 3.23 milliampere. That's it. Corresponding option that's going to follow is option C is correct. Option C is correct. In the 19th question, what they have given is, what is the value of accumulator AL and the carry flag after executing the following instructions? Move AL, 8EH. Nothing but AL is loaded with 8EH. Then you are going to load CL with 0 to H. Then you are going to shift arithmetic right AL, CL. Nothing but whatever the contents that is present in AL, you are going to perform left shift arithmetic by 2 times. By twice you are going to perform. Right? Whenever I am performing the left shift, so at that time it will be multiplied by 2, but here I am performing right shift. And also, what is the precaution you are going to take care? What is the precaution you are going to take care? Important. What is the precaution you are going to take care? Sign extension important. Sign extension important. MSB 1 is there. Rest of the values also you try to write the same sign extension only. Right? So, what is the value of AL you are going to have? The value of AL will be equals to 11100011. Nothing but E3. What is the carry flag contents, which will be equals to 1? What is the corresponding option that is going to follow? Option D is correct. Important. 20th question. High level language are translated into machine language by a program called as. So the option what they are given is assembler, compiler, modulator and linker. Which option you can eliminate easily? Right? That is a modulator, modem. You can easily eliminate. Now, for the 20th question, look at the things carefully. The corresponding option that is going to follow is compiler. It is going to convert the high level language to machine code, nothing but zeros and one. So, assembler, which is going to convert into assembly level language program. Compiler is the one which is going to convert into, it is a machine defined zeros and ones. Now, in the 21st question, what is the other alternative in order to clear the carry flag? If you are thinking that this question is a little bit tricky, you see. Anyway, we are in a position to write the program status words location. So, this is 0 and this is 7. 6, 5, 4, 3, 2, 1. That's it. This RS1 and RS0 is for bank selection. Now, this clear carry flag, how you are going to do? You are going to write a clear PSW.7. This is another alternative in order to clear the carry flag. So, for this, the corresponding option that is going to follow is option D is correct. What is the minimum sampling rate for the signal x of t equals to 3 into cos of 100 pi t? So, I can write it as a cos of omega t. You can rewrite it as a cos of 2 pi f t, which will be equals to, what is the value of a? You are going to get 3. What is the value of frequency? You are going to have frequency which is equals to 50 Hz. Now, what they are asking, what should be the minimum sampling frequency? The minimum sampling frequency should be Nyquist sampling. In the case of Nyquist sampling, what will be the sampling rate? In the case of Nyquist sampling, what will be the sampling rate? Which will be equals to 2 times of the highest frequency component of the message signal. What is the highest frequency component? You are going to get 50 Hz. 2 times of 50 will be equals to minimum frequency. How much you have to follow is 100 Hz. So, for this, the corresponding option that is going to follow is option C is correct. Anyway, we are going to choose, in practically we are going for oversampling, nothing but the frequency will be greater than 100 Hz. Important. 23rd question, the number of comparators required for a 5-bit flash ADC. The number of comparators that will be required in the case of a flash type ADC. We know that the time taken in the case of flash type ADC, it will be in the order of milliseconds, or sorry, it will be in the order of nanoseconds. How many number of comparators that is required is 2 power n minus 1, which is equals to 2 power 5 minus 1, which is equals to 31 comparators you are going to prefer or you are going to use. It is the fastest A to D converter. It is the fastest A to D converter. Practically not preferred. Why? Circuit complexity is more. Circuit complexity is more. So for 23rd question, option B is going to follow. How many clock pulses are required to serially shift a byte of data into the shift register? They are asking. How many clock locations or how many clock cycles are required means you are in need of 8 clock cycles. Because 8 bits are there. In order to shift bit by bit, you are in need of 8 clock cycles. For this, the corresponding option that is going to follow is option C is correct. Last question. Till here, you have not liked this video, please give it a big thumbs up. G of s equals to k divided by s into s plus 1 times of s plus 2. What is the breakaway point they are asking? So in order to find the breakaway point, dk divided by ds, which is equals to 0, k value you are going to take it as 1 and then you are going to solve. So here d divided by ds of k divided by, look at the things, s into s plus 1 into s plus 2, I can rewrite it as s cube plus 3s square plus 2s. dk by ds you are going to equate it to 0. Value of k you take it as 1 and then you are going to solve. What is the value of s you are going to get? So by making use of quadratic equation, you are going to get the value of s will be equals to minus 1.47 and the next value is minus 0.52, which is closer to minus 0.4226. Minus 0.4226. So the corresponding option that's going to follow is option A is correct. Option A is correct. Always a breakaway point should lie on the root locus. So the pole location, if I am writing, it will be at origin at minus 1 and at minus 2. Now look at the things here. In this region you will be having the root locus, because place a point over between the 0 and minus 1. On the right side, how many poles and zeros are there? Only one, odd numbers. So root locus is going to exist. Here between minus 1 and minus 2, no root locus is going to exist, or inverse root locus is going to exist. Important. Inverse root locus is going to exist. That is important. So friends, in this video we have discussed from question number 1 to question number 25. In the next part of the video, we shall discuss from question number 26 to question number 50. If you want me to solve any other set paper, please share the set question paper. So friends, if you have understood with this solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you. For test series, make use of cravingyan.com. Thank you.